Now we are ready to discuss object-oriented programming fundamentals of a Python. These are useful to understand PyUVM. So far in a CocoaDB, we have single async function which have an entire logic to apply the stimulus to a duty, capture a response, as well as to compare the response with an expected data. But when we deal with the complex duties, we need to separate each of the process with the help of a class. The process of applying the stimuli is an independent class. Likewise, process of receiving a response from the duty is handled by an entire different class. Likewise, comparison with an golden data is also handled by an independent class. So this is the methodology that is adopted in PyUVM also. So before proceeding to PyUVM, we'll understand how we build class-based test bench that greatly simplify understanding of PyUVM. The agenda of this course is to understand all the fundamentals of an object-oriented programming required to build class-based test bench. So far in the CocoaDB, we declared an independent variable for each of an input and output port. Class allows us to have a single container where we include all of the different data type required for our design under test. So our design under test could have multiple input and output port of varying size. Now class will be an object that will hold all of the data type required for an input and output port together. To start with the class, we add the language defined keyword class, and then we provide an user defined name to a class. Let us just name this as temporary class. Then to mark the start of a block, similar to a function, we need to use colon. Now inside this class, we won't be doing anything. Let it just add a pass over here. So this is how we declared a class which do nothing. We start with a language defined keyword class. Then we need to provide an user defined name to a class, then colon, and then an entire logic that we need to have inside the class. To access this class, the process is very simple. So we need to create an instances of a class. Let us just add an user defined instance of a class temp as T1, and this will be of type temp. This is how we use an instance of a class. Now, if you just try to execute the code, you'll be finding we don't get any error. So this is how we use the class. So here class behaves as a blueprint. Let us consider a simple test bench where we have one of a class named as a generator, which will be generating the stimuli for our duty. So that stimuli need to be sent to other class, which will apply to a duty, since we plan to use an independent class for all the process. So one of a class will generate the stimuli. Let us assume it to be a generator. Another class will be applying it to a duty. Let us assume it to be a driver. So generator will generate a random value, store it into containers for each of an input and output port. So class will basically have a different object based on the number of input and output port present in our duty. Generator will generate random value and store in an independent object declared for each of the input and output port. Finally, that will be sent to a driver where we have other class which store the data that we receive from a generator. So we require a class in both generator and driver to do different thing. In a generator, we will be generating a random value for each of an input port, whereas in a driver, we use the class to receive the data from a generator. Finally, we'll be applying it to a duty. So class that we declare will act as a blueprint. As and when we require that class, we will be creating an instance of it. So here, a class temp is basically a blueprint that will hold an object for a number of input and output port which are present in our duty. And then as per our requirement, for example, generator require one instance of a transaction class to hold the random data. We create an instance of a class to store the random data generated in a generator. Likewise, in a driver, we have an independent instance of the temp class to receive the data from a generator and apply it to a duty. So now you understand when we declared a class that act as a blueprint, and as and when we require it, we will be creating an instance of the class. So here, the way to create an instance is like this. So we provide an user defined instance named T1, and then provide the class name. Here, class name is temp. Again, two parentheses. So you'll be finding in most of the cases, this is not empty. In general, we'll proceed with an instance name, then add the class name, and then the parentheses. This is how we create an instance of the class. So these are the two things that you need to remember. The way to create class, you start with a language defined keyword class, provide a user defined name, then add the logic. To create an instance of the class, we provide an user defined name equals to, this is of class type.